We often make use of solutions. Tea is a solution of tea, hot water, and maybe sugar and milk that you put together and drink. Many chemical reactions also happen in solutions. Acid rain is a solution consisting of an acid dissolved in rainwater, and that can cause corrosion, can eat away buildings and stuff. Whereas if it wasn't a solution, if it was pure water, then it wouldn't do that. So solutions are clearly important to our everyday lives as well as to industry and so on. So we need to understand them. Now, a very important aspect of solutions is how strong the solution is, the concentration of the solution. To be able to work with concentration, we first have to understand what a solution is made of. A solution is always made of a solute dissolved in a solvent to make the solution. For example, it might be sugar dissolved in water to make sugar water solution. The sugar is the solute. The solute is often a solid, but it doesn't have to be. It can be a liquid, can even be a gas. And then the solute dissolves inside the solvent. The solvent in this example is water. And what the water actually does is it pulls, in this case, the sugar, the solvent. It pulls the particles making up the crystal apart from one another and goes in between them, and that then makes a solution. And in the solution you can't differentiate between the solute and the solvent. You can't see, oh, there's the sugar and there's the water, because it becomes a homogeneous, meaning the same looking throughout, evenly spread throughout, and indistinguishable. You can't tell them apart. So that's the solution. Now, the strength of the solution, the concentration of the solution, depends on how much solute there is per solution. The more solute there is per solution, the stronger the concentration. And that obviously is very important to know, because a very concentrated acid rain is going to cause more harm to your buildings than a weakly concentrated, a dilute solution. So a weak concentration is called dilute, and a strong concentration is called concentrated. So in what units do we measure this ratio of solute amount to solution amount? The standard unit that's been decided on is that we'll measure the amount of solute in moles solute and the amount of solution in volume solution. So it's in moles per decimeter cubed. Decimeter cubed is the standard unit of volume that has been decided on to be used for concentration. Moles per decimeter cubed. That means, though, that you're probably going to have to actually calculate how many moles of solute you have from the mass, the grams. Because when you're in the laboratory and you're busy making up a solution of sugar water or whatever, you're going to put that sugar onto a mass scale and get the mass of the sugar. And then from that, you'll have to calculate the number of moles of the sugar. And then it's very easy to measure the volume of the whole solution that you've made. You just simply use a measuring cylinder. So concentration is the ratio of the number of moles of solute per the volume in decimeter cubed of the whole solution. And the unit of concentration is moles per decimeter cubed. And a shorter way of saying that is molar, which is a capital M. Molar means moles per decimeter cubed.